हेलो गाइस, सो आज हम पढ़ेंगे डीएनएफ लोग एनसीईआरटी। सो उस वक्त थोड़ा मैं तेरे को मैं चैट लगा लूँगा, आप चैट लगा करेंगे तो देखने के लिए। ओके, सो लेट मी शेयर माय स्क्रीन। हेलो, माय स्क्रीन इज विजिबल। हियर वी कम विद डीएनएफ लोग elements. Okay, only for this one. So much. Let me get comfortable. So DNA block elements. Iron, copper, silver, and gold are among traditional elements that have played important development of human civilization, and the inner transition of elements such as THPA and DU are probably existent sources of nuclear energy in modern times. The D block of periodic table contains the elements of the groups 3 to 12, in which the d orbitals are progressively filled in each of the four long periods. The F block consists of elements in which 4f and 5f orbitals are progressively filled. They are placed in a separate panel at the bottom of the periodic table. The names transition metals and intransition metals are often used to refer to elements of D and F block respectively. There are mainly four series. Many four, there are the fuck. There are mainly four series of transition metals: 3D series C to Z and 4D series Y yttrium to cadmium, 5D series lanthanum to antimonum to Hg, and 60 series which has actinium and elements from rutherfordium to Cn. The two series of inner transition elementals 4F, CTLU, and 5F are known as lanthanoids and actinoids respectively. From the name, transition metals was derived from the fact that their properties were transitionally between those of S and P block elements. Now, according to IUPAC, transition metals are defined as metals which subside either in neutral atom or in their ions. Zinc, cadmium, and mercury of group 12 have full D10 configuration in their ground state as well in their common oxygen state. Hence, hence, not only regarded as transition metals, however, being the end members of 3D, 4D, and 5D transition series respectively, their chemistry studied along with chemistry of transition elements. The presence of partially filled d orbitals in the make transition elements different from that of the non-transition elements. Hence, transition elements and their compounds are studied separately. However, the usual theory of valence as applicable to non-transition elements can be applied successfully to the various elements also. Various species metals such as silver, gold, and platinum, and Italy important metals like iron, copper, and titanium belong to transition metal series. In this unit, we shall first deal with electronic configuration, occurrence, and general in this unit and general characteristics of the transition elements with special emphasis on the trends in the properties of the first row 3D transition elementals along with the preparation and properties of some component compounds. This will be followed by consideration of certain general aspects such as electronic configuration, oxidation states, and chemical activity of the transition metals. The transition elements develop. First topic is position in the periodic table. The D block occupies the large middle section of the periodic table, the flanked between S and in the middle periodic table. The d orbitals of the penultimate, penultimate energy level of atoms receive electron, giving rise to four rows of transition metals, that is 3D, 4D, 5D, and 6D. All these series of transition metals are shown in table. In general, the Electronic configuration of outer shell orbitals of these elements in is n-1d 1c10 and s1c2, except for palladium, where its electronic configuration is 4d10 5s0. The advanced one stands for inner d orbitals, which may have 1 to 10 electrons, and the outermost ns orbital may have 1 or 2 electrons. However, this generation has several exceptions because of very little energy difference from between n-1d and ns orbitals. Furthermore, half and completely filled sets of orbitals are relatively more stable. A consequence of this factor is reflected in the electronic configurations of CR and C1 3D series. For example, consider the case of CR, which has 3D5 4s1 configuration instead of 3D4 4s2. The energy gap between two sets 3D and 4s of orbitals is small enough to prevent electrons entering the 3D orbital. Similarly, in case of Cu, the configuration is 3D10 4s1 and not 3D9 4s2. The ground state electronic configuration of the outer orbital transition elements are given in table. Atomic number 21, 22 से 30 तक पूरे इसमें ऐसे ऐसे क्रोमियम में 1 होता है एंड सी में 1 बाकी सब में 2 2 होते हैं पूरे इसमें ओके 2D सीरीज ये जानते नहीं मोहब्बत तेरी रो रो पुकारे दिया चांद को वाई जेड ये जानते नहीं एन बी मोहब्बत तीसी रू रू पुकारे दिया चांद को ला हफ्ता ताऊ वरना रे उस आयरन पिटाई और होगी ला हफ्ता ताऊ वरना रे उस आयरन पिटाई और होगी लास्ट वाले की जरूरत पड़ती नहीं उनको मेंस में लिखे थे ए सी आर एफ डी वी एस जी बी एच एच एस एम टी डी एस आर जी सी एन ओके सर 2D सेकेंड सीरीज में हमारा क्या है वाई जेड आर और सी डी का 2 है पी डी का 0 है बाकी सबका 1 है ओके ये जरा चांद को तो पी डी 0 बाकी सबका 1 1 1 1 ओके एंड 3D सीरीज में 2 2 2 2 सबका 2 बस पी टी एंड ए यू का 1 1 ओके The electronic configuration of outer orbitals of Zn, Cd, Hg, and Cn are represented by general formula n-1d10 and h2. The orbitals in these elements are completely filled in the ground state as well as in the common oxygen state. Therefore, they are not regarded as the transition elements. The d orbitals of the transition elements protrude to periphery of an atom more than the other orbitals, that is s and p. Hence, they are more influenced by surrounding as well as affect the atoms or molecules surrounding them. In some respects, ions of a given D10 Dn configuration n is equal to 1 have similar magnetic and electronic properties with partially filled d orbitals. These elements exhibit certain characteristic properties such as display of variety of oxygen states, formation of colored ions, and entering into complex functions in variety of reagents. The transition elements, metals, and their compounds also exhibit catalytic properties and paramagnetic behavior. All these characteristics have been discussed in detail later in this unit. There are greater similarities in the properties of transition elements of horizontal law. In contrast to the non-transition elements, however, some groups similarity also exists. We shall first study the general characteristics and their trends in horizontal laws, particularly 3D law, and then consider some group similarities. Silver atom has completely filled the orbital in its ground state. How can you say that it is a transition element? इसका फूड एंड में फुल होता है। गुड क्वेश्चन। We will discuss the properties of elements of first transition series. Physical properties. Nearly all transition elements display typically metallic properties such as high tensile strength, ductility, malleability, high thermal and electric conductivity with metal luster. With the exception of Zn, Cd, Hg and Mn, they have one or more typical metallic structure at thermal temperatures. Hgp, Hgp. The transition metals, with the exceptions of Zn,